Good morning, everybody. So myself in Barasi, working as assistant professor in the Department of Electrical and Electronics Engineering from Mahendra College of Engineering, Salem. So let me talk about protection and switchgear. So what is the need of protection? So if protection is not provided, the electrical equipments will be damaged and it will cause severe injuries to the personnel working in the station also. So let us see the electrical power system. See, we all know that electricity is generated in a power plant, and in next stage voltage is stepped up for transmission, and then energy travels along a transmission line to the area where the power is needed, and then the voltage is stepped down at the load end, and finally it is given to the distribution side. So this shows the simple electrical power system, and this picture represents the single line diagram of an electrical power system. Here we can see the generator, the step up transformer, bus bars, transmission line, bus, transformer step down transformer, and finally the distribution end. Here it is shown as motors. So in protection and switchgear, we are going to provide protection for all these basic components, say generator, transformers, transmission lines, motors, as well as bus bars. So we shall see that one by one. So before that, we shall see the primary equipments and components that are needed in protection. So first is a transformer. This transformer is to step up or step down the voltage level, and then we are having the breakers in order to energize equipment and interrupt fault current to isolate faulted equipment. We use insulators to insulate equipment from ground and other phases. The switches or isolators in order to create a visible and permanent isolation of primary equipment for maintenance purpose, and bus in order to allow multiple connections to the same source of the power, grounding in order to operate and maintain equipment safely. So the arresters, nothing but the lightning arresters, which is used to protect the primary equipment from the sudden over voltage, that is from lightning strike, and the switch gears, integrated components to switch, protect and control the power flow, the reactors to limit the fault current, and the VT and the CT, nothing but the potential transformers and current transformers to measure the primary current and voltage and supply scale down to the metering and for SCADA purposes. Finally the regulators can be the voltage regulator, current regulators, and so on. So what is the need of this protection? See, there is no fault free system, and in order to ensure the safety of the personnel, we need protection, and in order to remove the component which is behaving abnormally by closing the trip circuit of the circuit breaker or by giving an alarm, and in order to disconnect the abnormally operating part so as to avoid the damage interference with the effective operation of the rest of the system, and in order to prevent the subsequent faults by disconnecting the abnormal operating parts, and to disconnect the faulty part as quick as possible, and in order to restrict the spreading of the fault current to the healthier system and to prevent the fault and to improve the system performance, we need protection. So generally there are 4 protection schemes. So one is overcurrent protection, and second one is the carrier current protection, the distance protection, and finally the differential protection. So normally this overcurrent protection is used in the protection of transmission lines, and this carrier current protection scheme is used in the protection of extra high voltage lines. Distance protection is used in the protection of transmission lines, and a differential protection scheme is used in the protection of generators and transformers. So we shall see about the current transformer and potential transformer, which plays an important role in the protection system. The current transformer is a type of instrument transformers which is used for measuring the high current and also in order to provide protection. So current transformer, it consists of 2 secondary windings. The first winding is usually designed for measuring purpose, and the second is used for the protection purpose. And also the current transformer secondary winding is always connected in star connection. So next is the voltage transformer. Again, voltage transformer is used in the protection purpose, and it is used for measuring high voltage of the system. This voltage transformer again consists of 2 windings, 2 secondary windings. The first winding is connected in star, and the star point is connected to earth, and the second winding is connected to delta in order to measure the high voltage and in order to protect the electric system. So what is the purpose of relay? A relay, it is simply a switch. The relay is the first part that comes in contact with the fault current, and this relay once senses the fault current, it gives the signal to the circuit breakers. So the types of circuit breakers, we are having a low voltage circuit breaker, magnetic circuit breaker, medium voltage circuit breaker, high voltage circuit breaker. What is a switchgear? A switchgear is a combination of switches, fuses or circuit breakers, normally used to control, protect and isolate the electrical equipments. It is used to de-energize the equipment, and it is used to clear the faults. So different elements of switchgear are shown here. We know the circuit breaker types: air brake circuit breaker, vacuum circuit breaker, oil filled circuit breakers, and sulfur hexafluoride circuit breakers. And recently we are using this MCB and RCCB, which is miniature circuit breaker, and the residual current circuit breakers. We can classify the voltages based on the range. So we call low voltage switchgears, which is ranging up to 11 kilovolt, and we can say up to 66 kV as medium voltage switchgears, and up to 400 kV we can call it as high voltage switchgears, and up to 765 kV we say it as the extra high voltage switchgear. Now coming to nature and causes of faults. So what are the reasons for the occurrence of faults? So insulation failure, conducting path failure, over voltages due to lightning or switching surges, breaking or puncturing of insulators, failure of conducting path due to broken conductors, failure of solid insulation due to aging, heat, moisture, over voltage, and accidental contact with the earth or earth screens, flashover voltages, and so on. So we know fault is nothing but the abnormal condition occurring in the electrical system or power system. Majorly we can calculate this or we can classify this fault as two types, one is symmetrical fault and the other one is unsymmetrical fault. The fault that is giving rise to equal currents in line displaced by equal phases of 120 degree in all the three phases is called as a symmetrical fault, or it is also called as three-phase fault. The unsymmetrical fault is a fault in which not all the line currents are equal and not have the same phase in all the three phases. So we can classify this unsymmetrical fault further into three types. One is single line to ground fault, a double line to ground fault, and line to line fault. So what are the abnormalities in a power system? So abnormalities are generally caused due to overload, short circuits, open circuits, and ungrounded equipments, surge voltages which are occurring due to lightning surges. So this picture, it shows the types of faults. The first one is the first picture shows the three-phase fault, which is the symmetrical fault. The remaining three, it denotes the unsymmetrical faults. When two lines are shorted, it is called as line to line fault. When one line is grounded, it is called as line to ground fault. When two lines are shorted and it is connected to ground, it is called as two line or double line to ground fault. And when all the three phases are shorted, it is called as the three-phase faults. So frequency of occurrence of types of faults, it is shown in the table here. The single line to ground fault occurrence is about 85%. The line to line fault is about 8%. The double line to ground fault is about 5%, and the symmetrical fault is about 2% or even less. So from this tabular column we can conclude that the most frequently occurring fault is the single line to ground fault. So with this we can conclude this. The remaining we shall see in the next video. Thank you.